metabolic profiles in dietary trials, which is also important in clinical nutrition and in clinical medicine, because it's a lot of it is about both compliance and effect. So I would start here with one of the outputs from the Football Consortium, Food Biomarkers Alliance collaboration that we had some years ago, and where we try to redefine biomarkers and what does it mean to have a biomarker. And we, Chen Gao is one of my postdocs at the time, or PhD students at the time, she drafted this figure, which is, the common division of biomarkers into exposure biomarkers, effect biomarkers, and markers of your health and susceptibility. And of course, this is where the exposure and the health are kind of fighting, is what extent of effect are you going to have from a certain exposure. Exposure is, of course, very wide. One of them is dietary, but it could be a lot of other things: medicine, physiological, psychological, and so on and so forth. So I'll talk mainly about exposure biomarkers, but also show how the triad here works together. Some years ago, together with Augustin Scalbea, we published an overview paper of all the different exposure markers. It's not only the food and diet, but you also have, of course, medical exposures, and you have also endogenous metabolomes. So you end up having a range of different metabolomes. You can also ask whether the diet is a sum of all the different foods, or whether you have to find biomarkers for every single food, or whether you want to look at the pattern and what happens there. So these are some of the enigmas currently of trying to figure out what people eat, because the other instruments that we have currently, the dietary instruments, where you ask people what they eat, they are having some issues. They are not very precise, and I'll come back to that. So, of course, what we measure depends on what kind of sample. We're measuring serum, urine, stool, and all of these samples, they kind of have their own timeline. Serum sample is a spot sample, only a single time point. Urine is collected over a certain period of time, at least in the bladder, but you can also have multiple samples that you enter into the same sampling, and you can also, and stools, of course, are very uncertain. How long time do they represent, actually? So you have all these uncertainties. We did a lot of studies with just simple meal studies. So any kind of food, and the subjects come in fasting, and then they have a certain amount of this food, and we take samples at several times. So it could be, for instance, at several hours, up to 24-hour urine, could be several 1, 2, 3 and more hours for plasma, and so on, in order to get some kind of idea of kinetics. And kinetics is really important here, because when you have a study like this and you have thousands of features in your metabolome, only some of them will have a reasonable increase and decrease again that tell that it is related to the dietary intake. Typically, a good biomarker of a food would be 0 if you've not been eating the food for a while, and then it would go to a certain level and start being excreted again. So this profile is what we look for. As a contrast, you'd say that an effect marker would probably be a compound that is there all the time, some endogenous metabolite that is then affected by the food and changing its level. So that would be another way of looking at it. So, of course, metabolomics on all these samples has been done. And I'll start with an example of in the area of alcohol. Here's the reported alcohol intake in a cross-sectional study, 139 people. And here is ethyl glucuronide, a biomarker of ethanol intake that is also used in forensics. So what is wrong? Do people not know what they are drinking, or doesn't the marker work so well? We try to analyze another marker completely independently, different system, different day. And what we see is that when we compare, for instance, ethyl glucuronide and ethyl sulfate, there is a very, very good concordance. So you can see this is a kind of a validation of one marker by another, and also showing that at least these two markers, they differ much from the dietary instruments. So obviously people have some difficulty in knowing exactly how much they drink. But this, I can tell you, is not only due to alcohol. We see the same for coffee, for instance. So it is kind of interesting that we see such, when it comes to quantitation, that we see such a bad concordance. When it comes to qualitative, did they drink or not drink, it's quite a bit better. We also in football worked on validation, and we try to look into literature. What does validation mean? What are people calling a validation? And we found out that there were at least 8 different criteria by which you could validate a biomarker. And these are then the goal. Then for any compound that you find, you can try to evaluate, see how many of these criteria does it fulfill, and what more studies do you need to do. So this is the strategy for single food biomarkers in order to get an idea of the total typically recent intake. So here's a nice figure by Natalia, who's also here, where you start out and you try to find out the early markers, and then you validate that as far as you can, and you have to do also cross-sectional studies. So from Natalia's work, I can show this nice figure where you can see a lot of compounds that come out when you give a few bananas or a single banana. And a lot of the, Martina, can someone try to, yeah, okay. So a lot of these markers are actually endogenous compounds, or they are not so rare compounds from the plant world. Here, terpenoid, and you can see that finding tryptophan or serotonin metabolites and so on would not be unexpected in the body anyway. So how do we go on from that? Of course, you can say that the pattern of metabolites, even from a single food, may be special. So by combining several biomarkers, it's possible to see that you actually get a very nice area under the curve of 0.89 different combinations. And this was done in a collaboration with the Cowen study in Germany. So what we see here is probably as good as it gets. So most often when we have a very well-controlled study with dietary intakes and very well interviewed subjects, then we don't get above 0.9 in the validation curve. So that's probably as good as it gets when you compare with these instruments. But still, it's very promising. You can see for several of these compounds, a very large difference, even if they are endogenous metabolites. And when you combine them, then you get a very good ability to discriminate between intake and no intake. So far, so good. Of course, the microbiome metabolizes our food. And here, together with Henrik, as the first author, made a nice paper on all the metabolites that are formed, and also the time course here, where you go from saccharolytic metabolism as far as you have substrate for that, onto proteolytic metabolism if there is no more sugars or carbohydrates left. So that means that you get a lot of different compounds that are from proteolysis if you have a long transit time. You can also see a range of the saccharolytic metabolites here, and they have effects both on the gut lining, but also more systemically, where they affect the whole body. For instance, the TMA that is metabolized into TMO and has effects other places increasing cardiovascular disease resistance. So this scheme is of course interesting to look for in dietary studies. And in another joint program initiative, Dynamic, we worked together with Danilo Aguilini at in Naples, and he made a UNINA intervention on Mediterranean diet compared to control diet in overweight subjects. So there was a baseline and 2 later time points that they were sampled. And in this study, we can find, of course, food intake biomarkers. They were given a lot of walnuts. So one of the things we could see there are urolithins. They increase much more in the Mediterranean diet than with the control diet. And also in the fecal samples, you see some increase of urolithins, and at least with the goodwill, some comparability with the urine and the fecal samples. Although, of course, the timing is different. Urolithins are very late excreted compounds from tannins, and therefore interesting to see also as a longer-term marker of intake. Another area was the proteolytic degradation, where you maybe see it most clearly in the urine, where there is a difference between the groups, but also the tendency towards lower levels of proteolytic degradation products, also of endogenous products. So here's peracresol sulfate and indoxyl sulfate. Over here we have the phenylacetylglutamine, which is part of one of the minor pathways of nitrogen excretion. And even if these 2 metabolites, the cresol and the glutamine, they come from very different pathways, they correlate, thereby indicating that they come, both of them, from protein that we need to get rid of, or that is being degraded in the gut. Last, I'll tell you about the cystitis study that, among others, Gerze was helping me with, but it was a consortium of all the Nordic countries. And there was studies going on in 4 of the Nordic countries, in Finland, Iceland, Sweden, and Denmark. And mind you, we have the same dietary recommendations in these countries. So we actually made a diet according to these recommendations. However, there is quite a distance, several thousand kilometers, both east-west and north-south. So that means that the foods are not exactly the same, even if the recommendations are the same. So they were overweight people with some criteria for metabolic syndrome, and they were divided into a healthy Nordic diet or controlled diet, and were not allowed to lose weight during these 18 to 24 weeks when the study took place. So in this study, it was not difficult to find difference between the 2 diets, no matter where you are. So a very good area under the curve here for discrimination between diets. However, if we look now only at the plasma markers, we can still see, and we take the markers that were discriminant and put them into a principal component analysis. You see very much the direction of the healthy Nordic diet here as compared to the control diet. We see a range of whole grain metabolites. We see a lot of fish metabolites. So the varied diet is much more clear, has a much stronger pattern than the control diet, which is relatively white and fat, and therefore mainly has some phospholipids as their markers. So this is more difficult. It's much more difficult to see white bread and fatty meals than to see a complex diet by metabolomics. So as I said, we have the fish direction to the whole grain direction here as the second principal component, with a lot of different markers, among them also many microbial biomarkers. So I would conclude here and say, by accurately classifying, validating, and combining biomarkers, it's possible to classify the recent intake of several foods and drinks correctly. I think there are around 30 to 50 foods at this time. We can identify misreporting and short-term dietary assessments. I didn't have time to show that, but for the alcohol, for instance, we found some people in a short-term study that did not comply. And we can identify a range of food intake-related biomarkers that are also affected by the microbiome. So we start seeing this interaction, and we can associate specific food intake markers with clinical effects to form qualified hypotheses about effect. Support from different sources, football and dynamic, and an EU grant, a Nordic Council of Ministers, and Carlsberg Foundation. Acknowledgements, a lot of people in my group who were involved here. I mentioned several of their names on the way, but there are more. And also the Football Consortium that we worked much together with. Finally, I would like to mention the Swiss Diet Consortium and the paper that came out there. We hope to soon be able to publish the data that I showed you here with a new evaluation of this study, and the Dynamic Consortium on microbiota with Danilo Ercolini here, who did the UNINA study. So thank you for your attention.